Alright, so we just did a little bit of a lesson that covered a little bit of this, okay? But just the properties of exponential functions and what they actually do. Okay, so the usual exponential function will go up like this. Okay, this intercept will be pretty much always 1, so 0, comma 1. Okay, and that's usually coming from the typical equation y equals a times b raised to the parentheses. I usually put x plus h, and then I put a plus k down below. Now that's going to look awfully confusing with everything and just really kind of mess it up. But if we take a look at this, this is going to be some really cool stuff. Okay, so this is your principal interest, and this is actually going to control this number right here. Okay, it's going to control the y-intercept. Now I'll explain why in a second. Okay, if this whole thing turns into 0, okay, well, it is going to be pretty much 0 plus nothing. When it's 0, this number is going to turn into 1. Okay, because anything to the 0 power is 1. Well, that just leaves this number and this number to kind of determine the fate of the y-intercept. Okay, so that's some really cool stuff right there. All right, let's get rid of that. Let's get rid of that. Okay. Alright, so that's what A does. Now, if A is negative, okay, that will flip this entirely over here. Okay. Alright, now B is the rate of growth or decay. So that is the rate. Rate is B. Okay, and like what we just talked about last time, if B is, well, there's some interesting things that B can be done with B. Okay, if B is less than 1 but greater than 0, whoops, let's move it over there. Okay, we're going to be dealing with what we call an exponential decay, and I'll show you that one in a second. And so it's going to be something that looks like this. Sorry about my little belly flop there and bounce up. Okay, but that just means we're going to be dealing with decay. Okay, however, right here, B is definitely going to be greater than or equal to 1. Well, it's not going to be greater than or equal to 1. It's not going to be equal. It's just going to be greater than. So let's get rid of that. Greater than 1. Okay, because if it was equal to 1, we would be dealing with this type of line. It would just be a straight up line, because if it's 1, 1 to any power is 1, and you know the A and the K will control it from there. Okay. Alright. Now this number right here, H, is going to control the left to right movement, just like every other single function we've talked about this year. If it's negative, it moves it to the right. If it's positive, it moves the whole function to the left. And K, same thing. If it's positive, it moves it up. If it's negative, it moves it down. Okay, just everything that we need to have happen has happened. Okay. All right, so something pretty simple like that. Now to take a closer look at B. Alright, now B is usually around 2, because if it's at 1, it's going to be straight line. Okay, but if I make it less than 1 but greater than 0, it's going to be an exponential decay. And just remember, there is an asymptote here at y equals 0, that this line, no matter how far over we get, and if we zoom in, you can actually see some gap between them. Okay, it's going to be really hard to see because we're pretty far out. But there is going to be a gap here. Okay, see, as you can see, if we go along the line, it's going to be really, it's going to be, I believe that's tens, hundreds, thousands, 10,000s, 100,000s. That's going to be 700,000ths of a place. Okay, so that's still not 0, but it's really, really, really close. Okay, it's something I don't want to mess with as much. Okay, and that's when B is going to be less than or equal to it. So it's just some really cool stuff that you can see with it. Okay, now if I go less than 0, this whole thing disappears, because what's actually happening is I'm making the rate or the growth or decay rate actually be 0 or less, which is not possible because it's negatives and zeros connotate a direction or a state of standstill. And you can't have an exponential function that way. Okay. Alright, so if it's greater than, it's obviously going to be a lot steeper, and just work with it. It's just really kind of cool how it works. Now A, once again, controls the y-intercept, okay, because of just the aforesaid motion of this B being raised to the 0 power. Okay. Now if I increase H, I'm just increasing the power. So that's technically what it's doing. It looks like it's moving left, but in fact, if you look really closely at the whole picture, it's going to be increasing the exponential power. And if I increase K or decrease K, K is the only one that can make this whole graph go into the negatives, because what you're doing is you're subtracting after the fact of working on the entire function. You're just like, oh, you did all that work, now I'm taking away a bunch. That's what that one's doing. So it's the only one that control an exponential function and make it negative. Okay? Alright, and normally you guys are going to be looking at something like this. Now if this was a little bit bigger, you know, you'd probably be talking about some kind of exponential model for money growth. Okay? Alright, but that is it for exponential functions and what they actually do. And please understand that you're just kind of messing around with it, moving it, and everything. Exponential functions work a lot different from the absolute value function and quadratic parent functions and cubic and all that stuff, in that you have to explain it a little bit more. Okay, so this number controls the y-intercept. This number controls the rate of decay or growth rate. This number up here controls what appears to be a left to right motion, but in fact is just increasing or decreasing the exponent. And watch, if I make h negative, okay, it just makes the exponents all lesser, you know. Okay, and remember, oh, another thing I forgot to talk about this last time. If the x is negative, well, it's just a reciprocal. That's all it is. So that's why we can have this negative over here, but we can't have a negative value because we're not going to get a negative answer when we raise something to a power. Okay? Alright. And then K controls the vertical shift up and down. That one's pretty simple. So this one is a lot like the others. A little bit, it's a little bit of, it's a similar thing. It's stretching it out vertically. B just controls whether we're dealing with growth of rate or decay. And then H, it doesn't do like it normally does, which is shifts it left and right. It does give the illusion that it does do that, but you just, well, it does. Yeah, it does. But just be careful to understand that when you change H, you're actually increasing the exponents or you're decreasing the exponents, so it's going to give the illusion of what it's supposed to do. Okay? Alright, that's it. Hopefully you guys have a wonderful day, and I will talk to you later. Bye.